Okay. The main aspect of this is looking at, well, I'll say the chapter or unit 4A is talking about inverses. And we've already done quite a bit. One reason why in trig we talked a lot about the inverse functions is we hit those aspects in the last unit, so we don't have to get into the trig inverses as much here. But the one inverse that you haven't learned that's most important here in this very short unit is the inverse of exponents. Because everybody just look at this real quick. Now, how do you solve this? If you have 625 is equal to 5 to the x, right? I mean, you could do trial and error. You could do 5 squared, that's 25. 5 to the third is 125. You can work your way up, but you would have to do more of a trial and error aspect. Now, when we have exponents that are easier to deal with, like when we have, say, 64 is, well, no, actually, I'm not going to go that route. I take that back. But the way we're going to solve is using log. And the way that we use the logs, because if you look on your calculator, there is a log button. And maybe this whole time you've wondered, what is that log button? And the log button is really just the inverse of an exponent. Just the inverse of the exponent. And the parts of the exponent sentence here, we can look at as 5 is the base. The exponent is x. This over here is often called the index. Okay, index. But looking here, how it is rearranged, is, remember, we use logs to figure out what the exponent is. So when I'm setting up my log sentence, I put the exponent as what I'm trying to find, right? So how do you solve this? How do you find x? Well, you set it up, you use logs, you put it in the log form, and what you're looking for is the exponent, and that's what we set up the log to find. X is the exponent, 5 is the base to my original problem, right? And here is my index. Okay. So essentially right now, all we're doing is converting, rewriting in the opposite form. The next step is going to be using the log rules to then solve and find the actual exponent value. But right now, all we're doing is, again, how do you solve this? Oh man, it's to the x power. I can't solve it. So what you do is you identify the base, you identify the exponent, and what you're doing is putting it in log form, which later in the next lesson we'll be able to solve and figure out what x is right here. Okay, so again, log base 5, we call this base 5. It's a little bit lower in how we write this. Log base 5 of 625 is equal to what x is. Okay. So again, the key is, if you have it in this form, identify the base, identify the exponent. Remember that logs help us find the exponent, so that's what goes over here. Within the log sentence, 5 is the base, and it is lower, just like a subscript, lower. Okay. So that's how we're going to go between these. Let's see if we can do a couple. All right, I'm going to keep highlighting the base in pink and the exponent in yellow. So we have 6 squared is equal to 36. And that's a true statement, right? It's a true statement. So if we get into the log form, all of this should work as well. Let's see what we get. 2, remember the exponent is what we're trying to find. 2 is equal to the log of, what's our base? 6. What was our index? 36. Okay. So essentially, we have it in this form, and the next lesson will allow us to use the rules of logs to show how this is equal to 2. Okay. Let's go the opposite direction now. Let's go from log base 4, 64 is equal to 3. And again, I'm going to go ahead and put the base in pink and the exponent, which we use the log to find the exponent, so I put that in yellow. So go ahead and just rewrite that. We know the base, we know the exponent. The index is 64. So we can put it over here in the exponential form. So first, I always look for the base, because with log form, the base is just this number here. Base 10 is standard, so next lesson we'll learn how to change this into a base 10. But base 4 means that it's 4 raised to what exponent? 3, good. And that's equal to 64. And let's see if that makes sense. You know, this is 4 times 4 times 4. 16 times 4, that equals 64. So yes, this did work. Okay. Okay. We just have a couple more here. I don't think I gave you none on the back. So let's look at this now. We have the base is b, the exponent is x, our index is 16. So what's gonna end up on the other side over here? Remember, we use logs to find the exponent, so we're gonna write the exponent is equal to log base 16. Okay. What I'm really just getting you used to right now is the spatial positioning of all these values. Okay, because once you can go back and forth really quick, then you can use the rules to solve them and get a little bit further with this. So here is my exponent, and the key, if you forget when you're in log form, if you forget which is the exponent and which is the base is always that lower value, log base y2, is equal to -8. And remember that we use logs to find the exponent. So the answer to a logarithmic sentence is going to be the exponent. That's where I can rewrite it over here. What's my base? Y. What's my exponent? -8. That equals my index. And that's mainly it for today. It's mainly for today just keeping in mind how to go between one form to the other form. Okay? Nice. Okay.